There will always be uncertainty in our estimates of the slope and y-intercept for a regression line, just like there is uncertainty in all estimates. This video explores the topic further by accompanying Open Intro Statistics' discussion of inference for linear regression. We will learn about inference for regression parameters using an example based on midterm elections and unemployment, where we will focus on understanding regression output from software. Elections for members of the United States House of Representatives occur every 2 years, coinciding every 4 years with the U.S. presidential election. The set of House elections occurring during the middle of a presidential term are called midterm elections. In America's two-party system, one political theory suggests the higher the unemployment rate, the worse the president's party will do in the midterm elections. To assess the validity of this claim, we compiled historical data to look for a connection. We consider every midterm election from 1898 to 2010, with the exception of those elections during the Great Depression. Here are the data in the corresponding linear regression. The estimated parameters of this regression relate the percent change in House seats for President's party and the unemployment rate. We might wonder, do these data provide strong evidence that the true linear model has a negative slope? We can frame this investigation using a one-sided statistical hypothesis test. The null hypothesis is that the true linear model has slope, represented by beta 1 of 0. The alternative hypothesis is that the true linear model has slope of less than 0. The alternative hypothesis would imply the higher the unemployment, the greater the losses for the president's party in the House of Representatives. Just like other point estimates we have seen before, we can compute a standard error and test statistic for the point estimates of the slope. This table shows output from statistical software for the least squares regression line in the unemployment example just introduced. We will generally label the test statistic using a t, since it follows the t distribution. The entries in the first column represent the least squares estimates, b0 and b1, and the values in the second column correspond to the standard errors of each estimate. We previously used a t-test statistic for hypothesis testing in the context of numerical data. Regression is very similar. In the hypotheses we consider, the null value for the slope is 0, so we can compute the test statistic using the t or z score formula. The test statistic equals the estimate minus the null value divided by the standard error, which is negative 1.15 in our elections example. The output from statistical software shows this information and also provides the p-value of 0.2617 corresponding to a two-sided test. Since we have a one-sided test, our p-value will be half that, which is approximately 13%. Consequently, we do not reject the null hypothesis. That is, the data do not provide strong evidence that a higher unemployment rate has any correspondence with smaller or larger losses for the president's party in the House of Representatives in midterm elections. Before moving on, it is important to note that if conditions for fitting the regression line do not hold, then the methods presented here should not be applied. In such cases, the standard error or distribution assumption of the point estimate, assumed to be normal when applying the t-test statistic, may not be valid. In this video, we were introduced to inference for parameters in a linear regression using an example from midterm elections. If you learned something you found interesting, share this video with a friend and visit openintro.org for more resources.